We are now looking at the pulleys as the second type of machine. The first one we looked at was levers. Now we are on pulleys. So our number 2 types of machines, the second one is pulleys. Now this is how a pulley looks like. If you have ever seen a tailor busy, you might have seen something which is as round as this. So a pulley also looks like this. Now, this round thing, we call it a wheel. And this wheel has a grooved rim. So there is a hole here where a rope passes. So this is a rope. So it comes from this way, it passes like this. So if you have a load down here, something which you want to raise up, you go this side and apply the effort down. And this load will move up. Now, as the load moves down, and yet the other side the effort is pulling, this rope is going to be tight. This word tension comes from the word tight. So this force we are representing it with the letter T, that is tension. It is a force. It is a force of resistance because it is pulling. It is going upwards while the load is going what? Downwards. So it is resisting the load. The two are acting in opposite direction. While the load is pulling down, the tension is pulling up. So this is briefly how a pulley looks like. Now the upper part is fixed. Why is it fixed? For support. So we have the effort, we have the load, we have the tension, and this is the string. And then we have a fixed support. Then here we have the wheel, which has a grooved rim. So basically we have how many forces here? The effort, downwards, you can see the direction. The load, we have not indicated the direction, but we can indicate the load is downwards, like that. Then the tension is what? Upwards. So those are the 3 forces we have there. So this is the diagram representing a pulley. So if somebody says, what is a pulley? Define a pulley. You have to mention the grooved rim, a wheel with a grooved rim. You have to mention the load acting on one side, and then the effort acting on the other side. So the effort is used to raise the load. So let us see this question. What is a pulley? And we are saying a pulley is a wheel with a grooved rim. So we have already mentioned this. It is a wheel with a grooved rim, round which a string rolls, you see. So there's a string which passes through the grooved rim. Then the statement continues with an effort applied at one end, overcoming the load at another end. So there is an effort on one side which overcomes the load. When you pull this effort down, the load goes what? Up. Now, where do we use these pulleys? There are so many uses, and that is the second question. B, state 2 uses. When we say uses, we mean applications. So when somebody says state 2 applications, it's the same as saying state 2 uses. So we are supposed to state 2 uses of pulleys. Where do we use pulleys? Now we use the pulleys to raise the school flags. So if you have ever seen somebody raising a flag, you must have seen a pulley somewhere. If you have not seen, next time you be keen a bit, you'll realize that there is a pulley somewhere up there. So we use the pulleys to raise the school flags. We also use pulleys in crane lifts, in lifting those big loads. Why should we suffer with big loads when there is a machine called a pulley which can simplify work? So in crane lifts, so this one is to lift the big loads. Like when they are building houses, you must have seen some machines which carry heavy loads and lift from one place to another. Some of those could be crane lifts. We also use pulleys for towing, in towing cars or breakdowns. Now, there are these particular cars which are being used to pull others. When a particular car has got an accident, there are those cars which come to pull those cars. So those cars which pull, we call them towing cars. Sometimes we call them breakdown. So those towing cars have machines, and the machines which normally they use for doing their work are pulleys. So we use pulleys for towing. So the examiner wanted 2 uses, but we have given 3. So how will you get your 2 marks? The first 2 answers will be marked. So if you mention 3 and yet we need 2, we shall mark the first 2, whether they are wrong or correct. Now here we have given you more than 2 for purposes, because next time they may say state 3. Now let us look at another question, that is part C. Mention 3 types of pulleys. By the pulleys also have types. So there is one we call single fixed. It is a single, it is one pulley, but it is fixed. So we call it a single fixed pulleys. There is another one which is a single but it can move. So we call it a single movable pulleys. Then there is the last one, we call it the block and tackle, which we are going to handle in a short while. So now let's look at the single fixed pulley, the first type of pulley. Supposing somebody says, draw, that is a question. Draw a well-labeled diagram of a single fixed pulley. From the word single, it means the pulley must be one. And then it must be fixed, so there should be a support. And in this equation, there are 4 marks, you see? So this pulley and the one we have just talked about is just actually the same. So a single fixed pulley has one pulley. It is fixed here. It has a support. One side is where you apply the effort. Then the load is somewhere here. The load could be a bucket of water. By the way, one of the uses of a single fixed pulley is used for drawing water from a well. So if this is your bucket full of water, so this is now your load. The weight of this water and the bucket, they are moving downwards. So the load is pulling downwards. But you are applying the effort from this side. So as you apply the effort down, what happens? Much as the load is also pulling down, this force tension is making the rope tight and is able to take this bucket up. So this is a single fixed pulley. It has a fixed support. It has an effort where you can apply at one end. It has a load somewhere here. The load could be anything. Here we are just giving an example of a bucket of water, but we are not saying the load must always be a bucket of water. No, it can be anything which you want to raise up. So here there's going to be a force called tension, as I said, but the tension is the same as the effort. So T means the tension, and then E means the effort. So this is the diagram. So as I've just said, the tension, we are now here. The tension which we are representing with the letter T is the force of resistance in the string. Why do we say it is a force of resistance? Because as the load is pulling down, the tension is taking up in opposite direction. Resistance comes from the word resist, to oppose. When you are opposing something, it means when we are moving towards the east, for you are moving in opposite direction. The opposite of east is west. So you can see the load is pulling down, but the tension is taking up. So it is resisting. So T is a tension and is a force of resistance in the string. And this tension is constant throughout the string. So it is constant. Everywhere, every part of the string, the tension is the same. So assuming there is no frictional force, if the weight of this thing is too small that we can neglect it, and there is no frictional force, how can frictional force fail to be there? If we don't want frictional force to be there, it means we put here oil. You know, you put oil, just like a bicycle. There is where you put grease. You know, why do you put grease? Because you don't want friction. A bicycle which has no grease, which has friction, always makes noise when somebody is riding. So here, if there is no friction, it means we have already done the oiling. So what happens? Once there is no friction here, and the weight of this thing is too small of the pulley, it means the effort and the load will be the same. And we have said it here, that if there is no frictional force, and we neglect the weight, The weight of what? Of the string. Then what will happen? The load and the effort will be the same. And once the load and the effort are the same, what happens? The mechanical advantage will be 1. Remember, we said mechanical advantage, you get it as load over effort. So if the load and the effort are the same, supposing the load was 10 newtons and the effort is also 10 newtons. When you divide 10 newtons, divide by 10 newtons, you get 1. Even if the load was 100 newtons and the effort is also 100 newtons, they are the same. As this statement says, 100 newtons divided by 100 newtons, you get 1. So once the load and the effort are the same, then the mechanical advantage becomes 1. The same story with the velocity ratio. Once the load and the effort are the same, it means the distance moved by the effort and the distance moved by the load will also be the same. Because the load is the same as the effort. So the distance the load moves, if the load moves down by 1 centimeter, the effort also moves the other side by 1 centimeter. So you find that the effort distance will be 1 centimeter. You divide by the load distance, which is also 1 centimeter. So your velocity ratio will also be 1. There's another type of pulley which we call single movable pulley. It is a single, it is one pulley, but it can move. You see? The other time we looked at the ones which are single, but they are fixed. Fixed means it cannot move. But this one is a single and it can move. So, single movable pulley looks like this. You have your pulley here, the rope passes or the thread, and then you have where you can attach the load down here. The load is always down. Then one side of the string is fixed. Then one side is not fixed. Now the side which is not fixed is where you apply the effort. And when you apply the effort upwards, what happens? This load and the pulley, the whole of this system will be moving upwards. You see? So it is a single, but it can move. So if somebody says, look at this question, draw a well-labeled diagram of a single movable pulley. Where do you score the marks? Here, there must be a fixed support, and there must be a rope. Here, the effort is the same as the tension, so you get the marks there. Naming here as the effort, which is E, you get the marks. And then this, the load, you also get, and then the pulley itself, you also get. So this is the diagram of a single movable pulley. You see? Now, in the same way, when we neglect frictional force and other factors, what are other factors? Now, I already told you that when you neglect the frictional force, it means you have already done the oiling, greasing of this machine. So there you have already catered for friction. What about other factors we are talking about? The other factors we are talking about are the weight of the string, this string here, and even the weight of the pulley. If it is too small that it can be neglected, then what will happen? The total downward force will be equal to the total upward force. What are the downward forces? The only downward force here is the load. What about the upward forces? There are two. There is E, there is E. You see this arrow? It is talking about the forces. Now this E is the same as T, tension. So there is E, there is E. So the total upward force will be E plus E, which is 2E. While the total downward force will only be L, which is the load. So we are saying, when we neglect frictional force and other factors, what happens? The two forces, the two sectional forces will be the same. The total downward force, which is the load, will be equal to the total upward force. Upward forces are 2, although they look the same. There is A, there is E. So we shall have the total upward force is E plus E, which is 2E. So our load, which is this one, is going to balance with the 2E. So if the load is the same as 2E, we collect the like terms. The like terms here are the letters L and E. Then we leave the number alone. So 2E means 2 times E. You see? If this was 2 plus E, it means I told you that the opposite of addition is subtraction. If this was 2 plus E, it means when you are taking this E this side, it would be a minus. But this is 2E, meaning 2 times E. Now, since it is a multiplication, when it crosses this side, it becomes a division. So E will come this way and it becomes L, you see, divide by E. And then this side will remain what? 2. So we divide both sides by E. Divide here by E, you divide here by E. So this E will cancel and you remain with the 2. Then this side you'll have L over E. And we all know that when you divide the load by effort, you're looking for mechanical advantage. So what does that mean? The mechanical advantage of a single movable pulley is supposed to be 2. What about the velocity ratio? You know velocity ratio deals with the distances moved by the load and the effort. Let's go back to the diagram. If this load moves downwards by, let us say, 2 centimeters, what will happen? This part of the rope will move upwards by 2 centimeters. This one also will move upwards by 2 centimeters, which means the effort has moved by 2 centimeters. You know the upward side is for the effort, then the downward side is for the load. So the total movement for the effort will be 2 centimeters plus 2 centimeters, which will be 4 centimeters. And what will be the load be having? 2 centimeters, while the effort will be having 4 centimeters. So what happens? Velocity ratio is the same as effort distance, which is 4 centimeters, divided by load distance, which is 2 centimeters. The centimeters cancel, you remain with the 4 over 2, and your answer becomes what? 2. You see? What about if this one moves by 1 centimeter? This will move by 1 centimeter, this is also 1 centimeter. The total movement up will be 2 centimeters, 1 plus 1. You see? So we can put it in the form of writing and say, if the load moves downwards by 1 centimeter, what happens? Each of the efforts E will be moving also by 1 centimeter. What does that mean? It means the total distance moved by the effort will be 1 centimeter each, but there are 2, so times 2. So you end up with 2 centimeters. So velocity ratio, we all know the formula is effort distance divided by load distance. So if the total movement by the effort upwards, because there are 2 E's there, is 2 centimeters, while the load has moved by 1 centimeter, what happens? These centimeters cancel. So you remain with the 2 divided by 1, and your answer becomes 2. So in summary, you can say the velocity ratio of this single movable pulley always will be 2. So we have the third type of pulley is called the block and tackle system. Block and tackle. You see? Just look at this diagram. This is how a block and tackle system looks like. When you look at this diagram, you realize that a block and tackle system will always have more than one pulley. In a single fixed pulley, we said the pulley should be only one. Single means one. And it is a fixed, meaning that does not move. Then in a single movable pulley, still the word single is there, meaning the pulley should be one, but this time it is able to move. But when you come to the block and the tackle, you will always have more than one pulley. So in this case, how many pulleys are there? 1, 2, 3, 4, 5. Now we are not saying they should always be 5, as long as they are more than one. More than one could be 2 and above, 2, 3, 4, 5, and so on. As long as it's more than one, it is a block and tackle system. So in our statement, we are saying here in the first sentence there, that a block and tackle system consists of more than one pulley mounted together. You see, very many pulleys, more than one, put together. Now, a block and tackle system is always very suitable for crane lifts, for lifting those heavy loads. You know, why do you think this one is suitable for that? Because it has very many pulleys. So these pulleys support each other so that they can be able to lift that heavy load. Now, more important, you should also know that it has 2 blocks. You see, the word is block and tackle system. Now, How many blocks are there? It has 2. Look at this diagram. You have 3 blocks up, and then you have 2 blocks. No, not 2 blocks. 3 pulleys up, and then 2 pulleys down. Now, these ones which are up, we call them the upper block. And then these ones which are down, we call them the downer block. So the block and tackle system has 2 blocks, namely the upper block and the lower block. Now, how do you determine if you have 5 pulleys? How do you always connect these pulleys? It is always good to put, the number of pulleys could be even number or odd number. Even numbers are those numbers which can be divided by 2, while odd numbers cannot. So if there were 4 is a number which can be divided by 2. What do you do? Whenever the pulleys are the same, they have even number, a number which can be divided by 2. What do? You also divide the same. You put 2 up in the upper block and 2 down. But if it is an odd number like 3, 5, 7, what do? You make sure that more are on the upper block and few on the lower block. I think this one also has some bit of common sense. Why do you think more should be up? Because the upper block is fixed, you see? This block here is fixed up. So if you have few down, remember when you apply this effort, what happens? These strings here are the ones which are supporting the lower block and the load. So when you pull here, these 2 will be able to move up. So if these 3 are, if more of the pulleys are fixed, then you will have a few things to lift. But if you put more of them down here and a few up, you will find that even lifting the very many, you need a lot of effort. So in brief, a block and tackle system consists of more than 1 pulley mounted together. It is used in crane lifts. It has 2 blocks, as I've said. We have the upper block and the lower block. Now, when somebody says draw a block and tackle system with the 5 pulleys, this is how you are supposed to do it. And how do you get the marks? The load must be there. The effort must be there. And the diagram with the fixed support, you see, must be there. And then these strings must be there. And in which direction? You see, these strings are supposed to be tight in such a way that much as the weight of these 2 blocks and the load, they are pulling the system down, but these ones are pulling up. So each one must have a direction, E, 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 E. So if you did it like this, you get all your marks. Now, let's move on. How do you get the velocity ratio of this system? The total upward force. By the way, which are the upward forces? The upward forces are here. E, another E, another E, another E, another E. Each string has E, So there are 5 E's. While the downward force is only L, the load. So if you are, now look at this statement. The total upward force overcoming the load. You see? The forces which are overcoming the load upwards are how many? There are E's, 5 of them. So all the forces upwards, the total upward force overcoming the load is actually E plus E plus E 5 times. So you end up with the 5E. So the load is balancing with the 5E. So it is mathematical, we can say L, which is the load, the downward force, is equal to 5E. As usual, we collect the like terms. 5E means 5 times E. So there's a multiplication here. So when we want this E to cross this way, what do? We shall divide both sides by E. You see? Divide by E, this E cancels. You remain with the 5. Then here you'll have L also divide by E. And we know that when you get a load divided by effort, you get a mechanical advantage. So this side, the E's will cancel and you get, so our mechanical advantage here will be 5. Now, what about the velocity ratio? We said if this load moves down by 1 centimeter, what will happen to the E's? Each E will also be moving by 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter. So when you add the total movement of the ease, the effort, it will be 5 centimeters. And for that reason, the velocity ratio will be effort distance, which is 5 centimeters, divided by load distance, which is just 1 centimeter. You know, these ones are very many, and the load is alone, you see? So the load will be moving by 1 centimeter, while the other is, because there are 5, each one is 1 centimeter, their total will be 5 centimeters. So your velocity ratio will be effort distance, which is 5 centimeters, divided by load distance, which is 1 centimeter. So let's put that in writing and say, if the load moves by 1 unit could be 1 centimeter, 1 meter, 1 millimeter. You see, if it moves by 1 unit, what happens? Each of the 5 strings, remember there are 5 strings there. Each of the 5 strings will be moving by 1 unit. You know, when the load moves by 1 unit, each one of them will be moving by 1 unit. But because there are 5, their total distance will be 5 units. So for that reason, how do we get velocity ratio? Effort distance divided by load distance. And when you divide the 5 units, that is for the effort, for upward movement, divide by 1 unit, that is for the load down, these units will cancel. So you remain with the 5 over 1, and your velocity ratio becomes 5. Now, to cut the long story short, although we are summarizing by saying velocity ratio here will be 5, whenever a question has been set and it is dealing with a block and tackle system where there is more than one pulley and somebody wants you to get the velocity ratio, you simply say velocity ratio is equal to the number of strings effectively supporting the load. You see? How many strings? Let's go back to the diagram. The load is this one. How many strings are supporting this load? Supposing you cut these strings here, like this, what happens to the load? It falls down, which means this load is supported by how many strings? 1, 2, 3, 4, 5. So if there are 5 strings supporting the load, then the velocity ratio is also 5. If there are 3 strings supporting the load, the velocity ratio is 3. If there are 10 strings supporting the load, the velocity ratio is 10. So what are we saying? That the velocity ratio simply means the number of strings which are effectively supporting the load. Another way of getting the velocity ratio of a block and tackle system, you say velocity ratio equals the number of pulleys. You see? Let's go back to the diagram. How many pulleys are there? 1, 2, 3, 4, 5. The pulleys are the round things. So you either use the number of strings supporting the load, or you say it is the number of pulleys. And that is a formula for getting velocity ratio. Now, back to this diagram. When you are drawing these pulleys, be careful. Make sure the first one is small, the next one is bigger than this. You see? The first one is small, the next one is bigger than this, the next one is bigger than this. Why? Because if they are the same, you will find that these strings will touch each other, and yet they are not supposed to touch each other. You see? And secondly, when you are drawing this diagram, make sure these strings are what? Straight. They should be tight. You know, when something is tight, it must be straight. But when you draw them like this, when they are bending, it means they are loose. How can these strings be loose when they are holding a load? You know, here they are being pulled, here there is a load. So all of them must be tight, they must be straight. You see, the way I have drawn. So that is how you draw them. So from today onwards, you should know that to get the velocity ratio of a block and tackle system, you simply count the number of pulleys or the number of strings which are effectively supporting the load. How do you know that the system is a block and tackle system? When the number of pulleys are more than 1.